You know that feeling, right? It's probably one of the best feelings for anyone who's into tech.
Oh, yeah.
You've ordered a new gadget, you've been refreshing the tracking number like every hour for 3 days, it finally shows up, the box is sleek, you crack it open, you get that new electronic smell.
They really should bottle that.
They really should, and you are just ready to build something incredible.
It's a special kind of optimism, that day one energy. You feel like, I don't know, Tony Stark in the cave.
It's exactly. Day one energy, you're ready to conquer the world. And today, we're talking specifically about the Arduino UNO Q. Because when you buy this thing, you don't just feel like you bought a microcontroller, you feel like you bought a ticket to the future. You're thinking, you know, web servers, AI integration, fancy motor control.
The marketing literally says infinite potential.
And you are here for it. You plug it in, you're ready to code, and then...
Nothing.
Yeah.
Silence. Or, if you're really unlucky, a very confusing red error message.
Connection failed. And just like that, all that infinite potential just hits a brick wall. We're calling it the setup wall. And if you're listening and nodding along because you're staring at a non-responsive board right now, don't worry. You are not alone, and you are not crazy.
And maybe most importantly, your board probably isn't broken.
That is the key. That's the reassurance we all need. So today, we're doing a deep dive into the Arduino UNO Q setup guide. But we're not just reading a manual. We're treating this source as the ultimate troubleshooting guide, because getting over this wall is surprisingly tricky.
It is. And our mission for this deep dive is to help you bridge that gap.
Yeah.
The one between the vision you had, the AI, the web servers, and the reality of a blank screen.
Right.
Because the source suggests that the reason so many people trip here isn't a lack of technical skill. It's just a mismatch of expectations.
The guide uses this phrase I love: expectations don't match the hardware reality, which, you know, sounds like relationship advice.
A little bit, yeah.
But for circuit boards. So let's unpack that. Why is this specific board, the UNO Q, catching everyone off guard? I mean, we've all used Arduinos before.
Well, that gets to what the guide calls the root cause, or a gap in recognition. Think about your mental model of an Arduino. When you picture the classic board, the UNO R3, what do you see?
I see a little workhorse. It's simple. You plug it in, the green light is on instantly, and it just runs your code. It's basically a toaster. You push the lever down, you get heat, done.
Instant gratification.
Yeah, you can drop it, you can wire it backwards for a second, and it usually forgives you.
That's the standard expectation. Rugged, instant, simple. But the UNO Q, it looks like an Arduino, same footprint, same headers, same logo. But inside, it is absolutely not a toaster.
So what is it?
It's a tiny, complex Linux PC.
Oh.
Yeah.
Okay, that's a big jump.
It is. And that's the aha moment the guide tries to hammer home. When you plug in the UNO Q, you're not just powering a simple loop. You are booting an entire operating system.
So there's a kernel loading, services starting, all that stuff happening in the background.
Exactly. File systems mounting, drivers initializing. It's a computer.
So treating it like a standard microcontroller is just... you're setting yourself up for failure from the start. It's like expecting toast in 2 seconds, but you actually plugged in a server rack that needs to run a whole systems check.
That's a great comparison. And because it's a PC-like process, you have to completely shift how you approach the setup. You can't just plug and play. You have to, well, respect the boot process.
Which brings us right to what the guide calls golden rule number 1. I love that they call them golden rules. It feels so official.
That's some gravitas.
Golden rule number 1, respect the heartbeat. What does that actually mean?
This is the most common failure point, and it's purely about behavior. The guide is very, very specific here about the technical requirement of patience.
How much patience are we talking? Because, you know, in modern tech, if a web page takes 3 seconds to load, I'm already annoyed.
You are going to hate this. The UNO Q needs up to 45 seconds to fully boot.
45 seconds.
45.
That's an eternity in gadget time.
It feels like forever. You plug it in, and for the first 10, 20, even 30 seconds, nothing really seems to be happening. The LEDs might flicker, but the system isn't home yet.
And the mistake is trying to upload code at what, second 15?
It's second 15,
Yeah.
because you're used to the old UNO being instant. But if you try to talk to it then, you'll interrupt the boot sequence or the handshake just fails.
And then connection failed.
Connection failed.
Yeah.
Because the brain hasn't even woken up yet. The USB stack isn't ready to talk to you.
Okay, so how do we know when it's safe? Do I need a stopwatch?
You could, but the guide gives you a specific visual cue. You're looking for the heartbeat.
The heartbeat.
It's a pattern on the LED matrix. It's not just a solid on light. It's this rhythmic, pulsing fade in and out.
Oh, like a breathing light.
Exactly. That pulse tells you the Linux OS is stable, the services are running, and the communication bridge is finally open. The guide is really clear. The heartbeat is the only sign the system is ready for input.
So the takeaway is simple but painful. Hands off the keyboard for pretty much a full minute.
Waiting isn't just being polite. It's a technical necessity. Trying to interact before that heartbeat is like trying to drive a car while the engine is still cranking.
You're just going to flood the engine.
Right. You're just going to get errors.
Okay, golden rule number 1. Don't panic. Wait 45 seconds. I can do that. I'll check my email or something. But let's play devil's advocate.
Okay.
I've waited. I've sat on my hands for 35 seconds. I see the heartbeat, but I still can't connect. My computer doesn't see it. Is my board broken?
Probably not. This is where the guide moves into what it calls basic hygiene.
Basic hygiene. Sounds like I need to get out some soap and water.
Please don't do that. No, it's about eliminating all the physical variables. But before you blame the tiny computer on the board, you have to look at the simple stuff. And culprit number 1 is almost always the cable.
Oh, the cable. I have a drawer full of USB-C cables. I just grab one. They all look the same.
And that is a very dangerous game with the UNO Q. The guide explicitly warns against charge-only cables.
I honestly forget those are still a thing. Why do they even make those?
They're super common because they're cheap. They come with, headphones, rechargeable toys.
Right.
So they have the power wires connected. Your board will light up. The Linux OS will boot. The heartbeat will start pulsing. But the data wires, they're just not there. They're missing internally.
That is so insidious. The board looks alive, it acts alive, but it's completely ghosting your computer.
It's the worst kind of bug because the visual feedback is lying to you. So hygiene step 1. Get a known, good, data-capable cable. Test it with your phone or a hard drive first.
Okay, check the cable. What's next on the hygiene list?
Direct connection. This is mandatory. Do not use USB hubs.
Oh, come on. My laptop has 2 ports. I live the dongle life. Why does this board hate my hub?
It's not hate. It's about stable power. Hubs, especially the unpowered ones, they introduce voltage drops and protocol layers. Remember, the UNO Q is a computer. During that boot process, it has these little current spikes as the CPU ramps up.
And a normal Arduino just doesn't care about that.
A normal Arduino is a microcontroller. It runs on bare metal. If the voltage dips a tiny bit, it shrugs. But a Linux kernel, if the voltage drops below a certain threshold, it panics. It's called a brownout. If your hub is splitting power with a webcam and a hard drive, the UNO Q might just crash halfway through booting.
Okay, that makes sense. It's high maintenance because it's high performance.
Precisely. Connect directly to the PC. Rule out power issues.
Okay, direct line. And I saw one more thing on the list, isolation.
Right. Minimal configuration, which means strip it down, remove all your shields.
Shields being the add-on boards you stack on top.
Correct. Yeah. If you've got a motor shield or a sensor array plugged in while you're doing the initial setup, you're just introducing variables. Maybe the shield is drawing too much power. Maybe it's using a pin that the bootloader needs. The guide is strict, naked board, only for the first setup.
Okay. Recap. Good data cable, direct connection, naked board. I've done all that. I respected the heartbeat. I'm ready. I open the software on my computer, the App Lab GUI, and I see a pop-up.
Ah, yes, the pop-up.
It says software out of date. And there's this big inviting green button that says update.
It's a trap.
It's a trap. But we're trained to update. Update everything. Security patches. Why is this a trap?
This is one of the most critical warnings in the source. It says, in no uncertain terms, do not press the update button in the App Lab GUI.
Why? What happens if I do?
You will likely enter a world of pain. Specifically, Cloudflare 500 errors and, more often than not, an infinite boot loop where the device just never comes back online.
That sounds aggressive. Why does the official software break the official hardware?
It's a versioning gap. The OS image on the board from the factory, the Linux it shipped with, is probably pretty old.
Yeah.
These things sit in warehouses for months.
Sure.
And the gap between that old version and the new one on the server is just too wide for that simple GUI updater to handle gracefully.
So it tries to jump across the Grand Canyon and just falls in.
Pretty much. It tries to patch files that have changed too much. It fails, it corrupts the file system, and now you have a very small, very expensive brick.
So the tool designed to fix it is the thing that breaks it.
Yeah.
That is incredibly frustrating for a new user.
It is. Ideally, it shouldn't happen, but in this specific out-of-the-box scenario, it does.
Which brings us to golden rule number 2.
Which is?
Trust the command line, the CLI.
Oh, I can hear people sweating right now. The command line feels like hacking. It feels like the Matrix. We want pretty buttons, not text commands.
I get that. It can be intimidating. But the guide promises this is the surest path. You need to bypass the easy GUI and use a tool called the Arduino-flasher-cli.
The Flasher-CLI. Sounds very utilitarian. It is. It's a specialized tool that doesn't just update. It performs a clean install. It wipes the slate clean and puts the latest OS image on fresh. It completely bypasses all those messy incremental updates that cause the crashes.
See, instead of patching a leaky roof, you're just ripping it off and putting on a brand new one.
Exactly. It takes a few more steps. You have to download it, open a terminal, but it works. And in this world, working is the only thing that matters.
Okay, so trust the CLI, but let's say I already clicked the button, I fell into the trap, I've got the Cloudflare error, my board is just blinking sadly at me. Is it over? Is it a coaster now?
No. And this is where the guide gets really cool. It introduces a recovery procedure they call emergency surgery.
Emergency surgery. Okay, now I'm picturing little scrubs and a scalpel.
Put the scalpel down, but grab a jumper wire. This is technically known as entering EDL mode.
EDL.
Emergency download mode. It's a low-level manufacturer recovery state. Even if the Linux OS is totally corrupted, the hardware chip itself has this tiny backdoor in the silicon that never dies. It's burned in at the factory.
That is very reassuring. So how do we do this surgery? Walk me through procedure step 1.
Okay, so picture the board. Step 1. Unplug everything. Patient needs to be offline.
Check. Patient sedated.
Step 2. Find the 2 little pins marked JCTL. On some boards, it might say boot. They're right next to the USB port.
Got them. They're tiny.
They are. Step 3. This is the critical part. You short those 2 pins together with a jumper wire. You make a little bridge between them. And this is the tricky part. You have to keep them shorted while you plug the USB cable back into the PC.
That requires some serious finger gymnastics, so I'm holding the wire on the pins with one hand and plugging in the USB with the other.
Yes, it's a bit of a maneuver. But what happens is when power hits the board, the chip sees those pins are connected and says, oh, we're not booting Linux today. We're going into emergency reception mode.
And how do I know it worked? Do sparks fly?
Hopefully not. You just listen. You'll hear that familiar USB connection sound from your computer, that little bling blong. Once you hear that, you can take the jumper wire off.
And then what?
Then you're safe. The board is basically in a coma, waiting for instructions. Now you go back to golden rule number 2. You open your terminal, you find that Flasher-CLI tool, and you run the command. Flash latest.
Flash latest. Just those 2 words.
Just 2 words. The CLI sees the comatose board, and it pushes a brand new, pristine operating system onto it. It takes a few minutes, but when it reboots... Heartbeat.
That is so satisfying. It's like bringing it back from the dead.
And the guide specifically includes a reassurance here. You will not damage the board. This is a standard manufacturer recovery method. You aren't hacking it. You're using the built-in safety net.
Okay, but I'm going to keep being the pessimist because I know how temps works. What if the surgery fails, I short the pins, I run the command, and it still errors out?
The guide is ready for that. It has a troubleshooting the fix section. Very meta.
Troubleshooting the troubleshooting.
It's necessary. So there are a few common errors. If you see waiting for EDL device and it just hangs.
The surgery failed.
It means the timing was off. The EDL entry failed. You probably let go of the jumper too soon or didn't have a good connection. The fix is just unplug. Try the jumper procedure again. It can take a little practice.
Okay. What about for Linux users? I know they always have their own set of headaches.
Right. If you're on Linux and see QDL unable to open USB device, that's a permissions issue. The guide says you need to configure your UDEV rules. Basically, your computer is blocking the tool from talking to the USB port for security.
Okay, here's one that would panic me. No space left on device.
Oh, this is a classic. You see that and you immediately think, my Arduino is full. I broke it.
Right. I haven't even installed anything. How is it full?
The expert note here clarifies this error is not about the UNO Q. It's about your computer. The Flasher tool needs to unzip the OS image into a temporary folder on your PC first. If your laptop's hard drive is full, the unzip fails.
So, go delete some old files and try again.
That's the solution. And finally, if you see server error or Cloudflare 500 while using the CLI,
it's not my fault.
It's not you. It's the Arduino distribution server.
Yeah.
It's down. Go make a coffee and try again in an hour.
It's nice to know that sometimes it really isn't your fault.
It's rare, but it happens.
You know, reading through this guide, it feels different. It's not like the manuals I used to get 10 years ago. It feels more honest about how complex things are.
That's a really keen observation. The guide actually ends with a section called The Future of Manuals, and it touches on this philosophical shift.
Yeah, it talks about how the box-to-blink experience is just too complicated now for a single piece of paper.
Think about it. When your hardware is running a full operating system like this UNO Q, the variables are infinite. Windows, Mac, Linux, different driver versions, USB controllers. A static PDF just can't cover it all. The manual would be the size of a phone book.
So where is the real manual then? If the paper in the box is useless, where do we go?
The guide suggests the true manual is built by the community. It explicitly mentions things like Senior Geek's troubleshooting log and community forums.
I love that name, Senior Geek's Troubleshooting Log. It sounds like a wizard spellbook you find in a dungeon.
In a way it is. We are all collectively defining the best practices. The manufacturer provides the hardware and the starting map, but the community draws in the detours, the shortcuts, and all the warning signs.
That's a really cool way to look at it. You're not just a user, you're an explorer mapping the territory for the next person who comes along.
We're all beta testers in the best possible way.
So let's wrap this up. If you are staring at an Arduino UNO Q right now and feeling frustrated, let's recap. What are the big takeaways?
2 golden rules. Number 1, respect the heartbeat. Wait the full 45 seconds. Do not touch it until you see that pulse. Don't panic.
And number 2, don't trust the GUI pop-up. Use the command line.
You do those 2 things and check your cables. You will break through that setup wall.
And on the other side of that wall,
Infinite potential. The web servers, the AI, the Python scripts, it's all there. The wall is annoying, but what's behind it is worth the climb.
I love that. And I want to leave everyone with a final thought today. We're seeing more and more of these simple devices turning into tiny, complex computers. My toaster probably runs Linux now. My doorbell definitely does.
It's inevitable. Compute is just getting cheaper and smaller.
So, does the responsibility for understanding all this complexity shift entirely to us, the users? Do we all need to learn how to short pins and run command line scripts? Or will the very definition of user-friendly have to change radically to hide all this from us?
That is the billion-dollar question for the next decade of tech.
Something to mull over while you wait that 45 seconds for your heartbeat. Thanks for listening to this deep dive. Go make something cool.
Happy making?